Make it smaller or bigger. And it's super easy how we do that. So if we make it bigger, we call it, we're enlarging it. And if we make it smaller, it's a reduction. Our scale factor is what tells us how big or small we go. And then in math, we always have a variable that represents typically what we're doing. So our variable for scale factor is k. If our scale factor k is bigger than 1, it's obviously going to make our image larger. Think greater than, large. If k is less than 1, it's going to shrink it down. What if our scale factor was 1? Anyone have an idea? Yeah, same size. What's anything times 1? Itself. So it's just going to be the same thing? All right, so it says graph and label each figure, and then we are going to dilate. So let's start by graphing triangle RST. R, -5, 1. Okay, if our k value is 2, is it going to get bigger or smaller? Bigger, because it's bigger than 1. Now that's how we do, folks. We're just going to take 2 times our ordered pairs. So what's -5 times 2?
-10.
-10. 1 times 2. 2. -3 times 2. -6. 4 times 2. 8. 2 times 2. And then -1 times 2. And now we just graph those. We just took our scale factor and multiplied our coordinates. -10. Pretty straightforward, right? Yeah. Should we try 2 or should we skip to 3? Think we need another practice of an enlargement?
No, I just did 2.
You did 2? Okay.
Yeah.
Should we just go on to 3?
Yeah, I think we're done.
I think we're okay. Let's try 3. Rhombus. JKLN. Does anyone know what a rhombus is?
Yes.
What makes a rhombus a rhombus?
Factor of 69.
What's that? I don't know. Does anyone know? We'll learn about it in January.
4 sides.
Yeah. What about those sides?
They're on.
They're all.
They're not all
They're
parallel.
parallelogram, yeah. But they are. All your sides are equal. It's like a square that's like squished a little bit to its side.
I was trying to say it was the diagonal lines were parallel.
The diagonal lines are perpendicular.
No, they're parallel. Like.
We'll learn. You'll know all the fun things about a rhombus later on.
Would you multiply by half?
Yep, that's all you do. So does yours look like all your sides are the same-ish?
Yeah.
Yep, and now you're just going to take and multiply everything by a half. So half of -10 would be -5. half of 2,
1.
half of negative 2, half of 8, half of 6, half of 2. You're losing our steam, that's okay. Half of negative 2 is negative 1. Half of negative 4 is negative 2. Uh-oh, where did I go wrong? L. Positive one. Shoot. How am I going to fix that? Omit the other guy. Guys, that's the real one. You guys okay if we do symmetry today? Notes tomorrow? Okay, let's move on to symmetry then. Okay, what's symmetry? Anyone know?
Line to the middle.
Yeah, same thing. Think of like a butterfly. Things that are equal on both sides. That's what I think of symmetry. We have 3 different types of symmetry that we are gonna talk about. The first one is line symmetry, and it's if your figure can be mapped onto itself by being reflected over a line. So do you guys agree if like I were to draw a line through here? Both sides are the same. If you have a hard time seeing this, someone so smart was like, take your phone, and it's like a little mirror, and if you go like this, up, and find your line of symmetry, you can see it makes a little mirror, and you'll be able to tell that it, just try it. Just try. If you put this like halfway through the triangle and like line it up, and it kind of acts as a mirror. You guys see how that works? Yeah, you see it? Does it work on your phone? Oh, you're
I have a
fancy.
Samsung, so mine doesn't work.
Oh, it doesn't work?
Dylan, shut up.
If you take a mirror too, it would work, but that's just a little way for you to check to see if it works. Oh, I see the same thing on both sides, on my paper and on my screen. What if you take your phone? You know,
Wait, how do you get a W?
I don't know.
okay, that's exciting.
Don't you see an M?
I see a W.
First of all,
Wait a minute, that is an M.
Does it work?
No, it's a W. Yeah,
that is a W.
it is a W.
Yeah, it's a W.
The N, if you mirror it, it's a W.
Is it? Let's all try. What do we get when we mirror the N?
It's a W.
That is a W.
No, it's not. Look.
Oh boy.
W.
It's a double.
From the Southern States.
We all need mirrors.
So,
I get an M.
Yeah.
Or an upside down W. Oh, does it?
This way.
There you go. I'm amazed by little things.
Oh! But it looks more like an M.
Looks
It looks
like
like
a
it
W.
was, an M is a W upside down.
Dude, it depends on which side of you put your phone on.
Yeah.
It's still a W.
Well, you have a screen on the back of your phone.
Okay, point symmetry, will you guys highlight this part? Is if you take a figure and just rotate it 180 degrees around a point. So it only works for 180 degrees. So if I take this N, and if I turn it 180 degrees, do I get the same thing?
Yeah.
So that's point symmetry. If you can flip it upside down, you get the same picture. Yes. Okay? And then our third one is rotational symmetry. And that's if, can I take this sun and move it a certain amount of degrees to end up with the exact same picture?
Yeah.
Does that make sense? So think of like a wheel, right? So that, those are our 3 different types of symmetry. Now we're just going to look and see if figures have any of them, all of them, or none of them. Okay. Let's try this.
One has all of them.
Does any of them have all of them? Well,
One
no.
has all of them.
No. Yeah, one has all of them.
Number 1 has all 3.
Yep.
So it has line. Where's my line through?
Huh?
Through the middle. Is that the only one?
No.
Where else?
Anywhere. Anywhere at all.
Not anywhere, but yeah, through any of our like vertices would work. So it has line. Check.
What?
Point. No.
Can't you go anywhere?
Well, what if I drew a line like this? Is that the same thing?
Oh, like, okay, never mind.
You know what I mean?
Yeah.
But you can rotate.
Does it have point symmetry?
Yes.
Can I flip it upside down and get the same thing?
Yes.
Isn't this nifty? Computers are the best. Yep, it has point. Does it have rotational?
Yes.
Yeah.
Yep. You can just turn it 180 degrees and you get the same thing.
That was,
Perfect. Should probably check it. Okay, what about our triangle? Does it have line? Where through?
right through the top.
Through the top. Is that the only place?
Yeah.
Yeah. Oh no, on all of them.
Yeah, go through all of them. Yep. Does it have point?
Yes.
Can I flip it upside down? Do I get the same picture?
Oh no, no.
Because that's not the same thing, is it?
No.
No. So it's not point, but does it have
No.
rotational? Yeah. Yep.
Wait, why is it rotational?
Because I can turn it 120 degrees and get the same picture. So here's where I start. If I keep going and going, oh, I got the same thing.
Oh.
You see it? Okay. What is this called? Does anyone know?
Parallelogram.
Yeah. Okay. What do we have? Does it have line?
Yes.
Where?
No. Cut it right through the corner and the bottom corner. Yeah, like that.
Do I get the same thing on both sides?
Yeah.
If you were to fold it, though,
No, you wouldn't. No.
does that fold on top of each other perfectly?
No.
No. So it doesn't have line.
No.
No line. What about point?
Yes.
If I take
Oh,
it.
if you spin it, no.
What?
No.
Oh no. 180. Do I get the same thing?
Oh yeah.
All
My
right.
bad.
Rotational?
Yes.
Yeah, we just did it.
So if it has point symmetry, then it definitely has rotation symmetry.
But not if it has rotational, it doesn't.
Perfect. Nailed it. What about our right triangle over here? Does it have line?
No.
No.
No. What about point?
No.
No.
Rotational?
No.
No.
Big old no. Okay, why don't you guys try the last 4, see what you come up with on your own, and then we'll talk about it together. Does anyone need like patty paper so they can like trace it out and like flip it around? Does that help anyone? For whatever reason, this is hard for me. Like I can't visually see it without manipulating it. Trace that out. So you want to come do 5 on the board? Anyone? What do you guys put for 5? Does that have line? Yeah. Point? Can I flip it upside down and get the same picture?
No.
No. Is that rotational? Yeah. What about 6? Line?
Yeah.
No. No.
Not line.
Why not?
Because you can't.
Where? Can you come? Oh, maybe we're all wrong, but you can
Logan,
try.
Logan,
Can you draw a line
fold it?
anywhere through here and get the same picture?
No. So if you folded it,
What's that?
if you folded it, it wouldn't go on each other.
Okay. Does it have point? Yes.
Wait, can you explain point again?
So that's when you
Flip
just
it
take
upside
it
down.
and just flip it upside down. Do I get the same thing?
Oh, okay.
Yep. And if it has point, we know it has rotational. It's a 2 for 1. Okay, what about the letter A?
Question.
Line, yes.
Yeah.
So if you look down, like, can't you put a line through both corners, like far corners of each one?
No.
6.
No.
Here, come draw. Just come draw. Let's talk about
If
it.
you hold it, then it's not on the.
Like if you do it-
Watch.
This way?
Nope,
If
if
you
you
pull
hold
the,
it.
oh, hold on.
You want to believe it's because they're not connected. You see why? Like there's nothing over there that matches this part. You see that?
Oh.
What'd you guys get for 7?
Line, yes.
Line, I agree. Point.
That's it.
No.
Rotational?
No.
Just line.
Wait, now what's rotational?
If you can flip it less than 360.
So can I rotate this at any degrees where I'll end up with the same
Oh,
picture?
okay.
No.
Okay, we're good.
You guys are all A students in my heart. Okay,
In your heart.
in my heart.
But not in your soul.
Not
Not in
In
the
my
grade
soul.
book.
Maybe not in the grade book. I don't know. The Harry Potter one. What do we
None.
think?
none.
No, we did this in like kindergarten. So. Actually, we did.
Well, great. Super.